here's our first 3 practice genetic problems. And if you can do these 3 problems, honestly, you've got 2/3 of the chapter down already. So, first, tall plants are dominant over short plants. As soon as they tell you that, you should, in your head, come up with this kind of terminology. Big T, little t would therefore both code for tall, and little t would code for short. That's what they're basically telling you. Now they say they're crossing a heterozygous tall plant, so that's big T, little t, with a short plant. They didn't say whether the short plant was homozygous or heterozygous. They don't have to, because as soon as they say short, there's only one code for short, because short's recessive. So you're crossing with little t, little t. Okay, we only need, if we're going to do a Punnett square, we only need 2 boxes. If you do it with 4 boxes, it's not wrong, but it's not necessary. And then if they ask for the genotype and phenotype ratio, the genotype ratio would be that half would be big T, little t, 1/2 would be little t, little t. You could also say 50% and 50%. You do not have to use fractions. You can use percents. For the phenotype ratio, which is basically telling me what they look like, it would be that 1/2 or 50% would be tall, and 1/2 or 50% would be short. For the second one, this is a classic kind of genetics problem where you have to work backwards. So they don't tell you whether black or white is dominant. They also don't tell you what the parents are. They give you the offspring instead. So first, okay, you crossed 2 black rabbits. Notice that the offspring come out 3 black and 1 white. The fact that they made more black than white would be a clue that black is dominant, but there's an even bigger clue. If black was recessive, then the 2 black parents would have to be little b, and little b, little b. There's no way, if that means white would be dominant, and white would have to have a capital B. There's no way 2 black parents could make a white offspring if black was recessive. So black must be dominant, and white must be recessive. So now that we know black is dominant, we know that the rabbits have to be big B something and big B something, because that would make them black. The clue is the fact that the offspring comes out white, or one of the offspring is white. The only code for a white offspring, because now that we know that white is recessive, is little b. And the only way that these 2 parents can make little b is that both of them have to be carrying a copy of little b. So our 2 parents have to be heterozygous. If either of our 2 parents was homozygous, like this, it would be impossible to get a little b offspring because this parent would always give a big B. Last cross. This one is really looking to see that you understand the genetics vocabulary that we've covered. Homozygous black is crossed with a homozygous white. So that's going to be big B, crossed with little b. You really don't need a Punnett square to solve this. We know they're all going to come out big B, little b. Now they say to cross the F1. So the original ones are called our P generations. It's just like one of Mendel's crosses. Our original purebred parents are our P generation. When they say to cross our F1, what they mean is cross 2 of these with each other. They will never tell you to cross the F1 if all the F1s don't look alike. So when they say cross the F1, that's a clue that all the F1s should have come out the same. So we're going to cross the F1 with another F1, meaning cross 2 of these, like this. And the offspring we get are going to be our F2, which is what they're asking for. So this would require 4 boxes, this Punnett square. And if we fill this in, we're going to give the genotype and the phenotype ratio on this problem. So first, our genotype ratio would be 1/4 or 25% big B, 1/2 or 50% big B, little b, and 1/4 or 25% little b. Our phenotype ratio would be that 3/4 or 75% would be black, because any of them, this one, or this one, that are carrying big B would be black, and then 1/4 or 25% would be white. If you're able to do all 3 of these problems, then you really have the understanding of this chapter down, and although we are going to learn a few more things in the next couple of days, you shouldn't struggle with any of it if you understand, if you were able to do these. So that's a good sign.